What if I told you that the universe may have no beginning at all? No first second, no cosmic birth, no moment when everything started. For a long time, some scientists believe that the universe has always existed and will always exist. Even though galaxies are moving away from each other, they believe the universe could still look almost the same forever. This idea is called the steady state theory. But when did scientists believe it? How could an expanding universe remain unchanged? And what observation almost destroy these theories? Let's find out. The big question. One of the biggest question in the science is, did the universe have beginning? Did the universe have beginning? Today, the most expected explanation in the Big Bang model. It says that the universe was one extremely hot and dense, and the space have been expanding and cooling ever since. But during the 1940s and 50s, scientists did not have enough evidence to be fully certain. There are two major ideas. First, the universe began in a hot, dense, early state, what later became known as the Big Bang model. Second, the universe has always existed and will always exist. The second idea was the steady state theory. In 1948, the scientists Hermann Bondi, Thomas Gould, and Fred Hoyle developed important version of this theory. The main idea of the steady state theory. The steady state theory says that the universe is expanding. Yes, galaxies are moving away from each other. But according to this theory, the average appearance of the universe never changed. Imagine a large hall full of people. Now imagine the hall is continue becoming bigger. Normally, the people would become more spread out. But what if the new people quietly appear in the empty space? Then, ever thought the hall expands, the average crowd density stays the same. That is exactly how steady state theory explains the universe. As galaxies move apart, new matter would continuously appear in the empty space. That new matter could eventually form new stars and galaxies. So the universe would keep expanding, but its average density would remain always constant. So the universe would expand, and but its average density would remain always constant. The perfect cosmological principle. The theory was based on something called the perfect cosmological principle. It says the universe is similar everywhere in the space, in every direction, and even at time. The normal cosmological principle says that on a very large scale, the universe look roughly the same in every direction. But the steady state theory add one extra idea. The universe should also look roughly the same in the past, present, and future. This means the universe has no special beginning and no final ending. It is external. The stars may die, galaxy may change, but overall the universe always remains statically similar. But where does new matter came from? But where does new matter came from? Now comes the strange part. If the space expands, matter become more spread out. To keep the density constant, new matter must be created. To keep the density constant, new matter must be created. According to the steady state theory, this creation would happen extremely slowly. This creation would happen extremely slowly, slowly that we would not directly notice it in daily life. Notice it in daily life. A tiny amount of matter would appear in the space mainly as the simple particles such as hydrogen. Over billion of the years, this matter could collect due to gravity and form clouds, stars, and eventually galaxies. Form clouds, stars, and eventually galaxies. This was not magical in the scientists' minds. They were trying to build a mathematical model that could explain an expanding universe without requiring a beginning. Fred Hoyle introduced continuous matter creation into the equation of general relativity to create an expanding but overall stationary universe. Why did scientists like this theory? The steady state was attractive for several reasons. The steady state was attractive for several reasons. First, it avoided the difficult question, what happened before the beginning of the universe? What happened before the beginning of the universe? According to the steady state theory, there was no before because there was no beginning. There was no before, there was no beginning. Second, some scientists felt uncomfortable with this idea that the entire universe began from an extremely hot and dense condition. Third, at that time, evidence for the Big Bang was not as strong as it is today. In the 1950s, both theories were seriously discussed by the scientists. NASA educational material notes that at that time, observations were not yet enough to clear decide between the steady state and the evolutionary universe model. So this was not a silly idea. It was a real scientific theory competing with the Big Bang. The steady state versus Big Bang theory. Let's compare the two ideas. In the Big Bang model, the universe changed with time long ago. It was hotter, denser, and smaller. As time passed, space expanded, galaxies formed, and stars formed. And the universe cooled down. In the steady state model, the universe has no beginning at all. It expands, but new matter is continuously created. Old galaxies move further away, while the new galaxies forms in the space left behind. So the universe always look broadly similar. Think of the Big Bang model like a movie that has starting scene, but the steady state universe is like never ending live stream. There is no first frame and no final frame. The discovery that changed everything. They come one of the most important discovery in the cosmology. In 1965, two radio astronomer named Arno and the Robert Wilson decided a strange microwave signal detected a strange microwave signal. No matter where they pointed their telescope, they found the same faint background radiation. It seemed to come from every direction in the sky. The radiation became known as the cosmic microwave background or CMB. Scientists understood that this globe was leftover radiation from the early universe. This was the leftover radiation from the early universe. It was like a faint afterglow from a hot beginning. The discovery of the CMB strongly supported the Big Bang model and created major problem for the steady state theory. Why was the CMB a problem? Here is why cosmic microbackground was such a big problem. The Big Bang model predicted that if the universe was one extremely hot, it should left behind radiation. As the universe expand and cools, the radiation would stretch into the microwaves. And that is exactly what scientists found. Today, the CMB fills the universe as a temperature close to 2.7 Kelvin, just above absolute zero. Today, the CMB fills the universe and has a temperature close to 2.7 Kelvin, just above absolute zero. It's like seeing the oldest light in the universe. It is like seeing the oldest light in the universe. Steady state theory did not naturally predict it. Such a universal glow from a hot early phase. Scientists tried to modify steady state model, but the evidence increase supported a universe that changed dramatically over time. Measuring from these missions such as COBE, WMAP, and Planck later mapped tiny variations in the CMB, tiny temperature difference that helped explain how galaxies eventually form. The universe has changed over time. Another issue was the astronomers start seeing the evidence that the universe was not the same at all time. Started seeing evidence that the universe was not the same at all time. When we look far into the space, we are also looking back in time. Light was very distant galaxies take billion of the years to reach us. Light from very distant galaxies take million of years to reach us. So the distant galaxy shows us what the universe looked like long ago. What universe looked like long ago. Astronomers found that the early universe has different populations of the galaxies, quasars, and the energetic object compared with the nearby universe. This suggested that the universe has evolved. It has a history. It has a history, and that direct conflict with the main idea of the steady state theory that the universe should look broadly the same at every time. Broadly should same at every time. And the steady state theory completely dead? Is steady state theory completely dead? The original steady state theory is no longer accepted by most cosmologists. The original steady state theory is no longer accepted by the most cosmologists. The evidence for an evolving universe is extremely strong. The cosmic microwave background, the expansion of the space, the abundance of the light elements such as hydrogen and helium, and the evolution of gases all fits much better with the Big Bang model. All fits much better with the Big Bang model. However, steady state theory is still important. However, the steady state theory is still important. The question arises is why steady state theory is still important. Because science is not about blindly accepting the most popular idea. It is about creating testable explanation and comparing them with evidence. It is about creating testable explanation and comparing them with evidence. The steady state theory made predictions. Scientists tested those predictions. And when the better observation disagrees with the theory, the scientists change their understanding. That's how science moves forward. That's how the science moves forward. Coming to the next chapter, what we can learn from it. The story of the steady state theory teaches us something powerful. A theory does not fail because it is unpopular. It fails when observation do not support it. It fails when observation do not support it. At one time, steady state theory was one of the biggest idea in cosmology. Today, it is the mostly a historical theory. It is mostly a historical theory. But it played an important role because it forced scientists to ask difficult questions. Forced scientists to ask difficult questions. Does the universe have a beginning? Does the universe have a beginning? Can matter be continuously created? Does the universe change with time? Does the universe change with time? And what evidence can prove or disprove these ideas? What evidence can prove or disprove these ideas? These are the questions that help modern cosmology grow. So let's come to the ending. So, did the universe always exist? Did the universe always exist? According to the steady state theory, yes. It has no beginning, no end, and always look broadly the same. But modern observation tell a different story. The universe appeared to have a long history, a hot early phase, expansion, cooling, galaxy formation, stars, planet, and eventually us. Steady state theory may not be accepted model today, but it remains one of the most fascinating ideas ever proposed about our universe. But sometimes even an incorrect theory can lead scientists toward a better truth. Point to be noted that incorrect theory can lead science towards a better truth. What do you think? Should the universe have beginning or could it be always existed? Write your answers in the comments and I will meet you in the next one. Till the time, bye bye.